Hello everyone, I'm sorry this episode got cut short because of a OBS crash. So there's no ending to this and it ends very abruptly, but it's still about 30 minutes, so I hope you enjoy.
Or squirrels or cats or foxes or something like that. But he's a lovely dog. He's as soft as grease, and he's lovely. It's the best way to put it.
And that's your Handmade After Dark intro, everybody. Welcome to another episode of Handmade After Dark, where I'm joined by three lovely gentlemen. One that is, well, okay, I say lovely, but one is an asshole, that one's a great guy, and one hates operator overloading and function overloading. Why is that, Phil? What is your continuous war against easy function overloading?
You have no use for it. I was back in your building. What do you need it for?
My problem is, it's not that I don't hate it. It's like I'm trying to figure out if it's actually needed.
It is.
It's not wanted. No, not wanted. Needed.
It's not needed.
There's no needed, in my opinion, and it's called ad hoc polymorphism for a reason. It is ad hoc.
Now, here's my question, though: is what about generics in general? What is your
No, I'm not against
generics?
that. I'm not against parametric polymorphics, as it's called, or subtype polymorphism. I'm against ad hoc polymorphism, which
But
is
here's
overloading.
the thing: is that okay? So I'm not a fan of generic programming in general. Like, even no matter how nice you make it with error messages and stuff, I think I've come to the conclusion that the basic way we do, where it's kind of like you have a variable type and then it
Yeah.
can be compiled in multiple ways. I'm not sure that I'm convinced by that in general, because even if you make that as nice as possible to use, it's just like now I'm trying to make one piece of code that does 10 things, and like, I don't know, that feels like you're getting into the land of tricking your compiler into doing the right thing rather than just getting the thing you want, in a sense. But I would say if you do care about that, I feel like overloaded things matter, because you want to be able to write functions that are like, here's my generic, and I can pass in either an A or a B, and I need the overloaded functions that I pass those to correctly use the types. You know what I mean?
I completely agree with that point as well. It's a really weird decision, and it's like it's really difficult to think about as well, because when you're programming in C, you cannot have overloading whatsoever. So one function applies to one function only. The name only applies to one thing. It's a one-to-one relationship. And when you're programming, it's quite nice because you can just grep the thing. Like, I know exactly where this thing is. When you have overloading, there are numerous places where it could be, and you have to depend on what the actual type is in the context that you're programming in. And it's quite difficult to understand where that comes from. And there was a stream that Sean Barrett was doing last night or the night before, I can't remember the exact date. And I was actually asking this question, and it kind of spawned off a quite bad chat thing, and it kind of went on, it kind of spammed on for a few hours. It was a bad idea. But I was asking, like, do you think that overloading is needed in a modern language? And he kind of said no, because it doesn't actually solve the problems that you're trying to solve. And what you're talking about with like generics or like parametric polymorphism is the technical term for it, is that it doesn't actually help you. It only helps you in mathematical types.
Yeah, it just besides
That's
that,
the only time it actually helps you is for mathematics.
Yeah, I just put it in for him in math. That's the only reason I put operator and function overloading in. I personally don't like it, but I know like a lot of people like it for math and stuff like that. Just like you just call add instead of add vec too. So it's like,
yeah. Personally, operator overloading, I couldn't care. I don't care. But I used function overloading a lot for things that essentially like for when I just want to pass different parameters, but the output is the same. Basically, I want to.
No, completely.
For example, if I want to, let's say I pass something a struct and then with the height, because I want to or a small subsection of it, or I can just pass the struct and take the entire thing. But now I have to call two different names, even though I personally don't care. But I get your grep argument and that sort of stuff. But generics is something I use a lot.
Generics is a completely different thing. It's not actually anything to do with
Oh,
overloading.
yeah, but like, I was more
No,
to
but
what
that's
orthogonal concept.
what Alan said, like how he doesn't subscribe to the theory of generics.
Yeah, I don't either.
I use them regularly. Like I think they're amazing for not just mathematical stuff, but also, like, for example, if I have a list, like that's one of the most useful use cases, in my opinion. How I can have a type safe list without having to fucking retype the entire fucking thing again and again.
No,
again
I
and
completely
again.
agree with that as well. I've been programming in Go for about 3 years and about 1.5 years professionally with Go. And Go has no generics whatsoever default. You can generate generic code easily. Like you can just have like a preprocess that generates the code what you need for it.
Go has
But
preprocessing?
kind of. I won't go into that. It's
I'm just
quite
saying,
really a discussion.
I've, as you know, missed a little
You
bit
can
around with
generate a lot of Go code, and there is some standard library stuff that allows you to do that, but it's not recommended is the short answer of it. But Go, what I'm finding is that you don't really need the generics because you're trying to solve a certain problem, and you've got the code to solve that. Then you've done it. You don't need a generic solution because you've only got one problem with one solution.
See, but that's me in 99% of cases.
Well, that's it.
I don't need generics because I'm solving a specific problem. I'm not solving it for everything. I have a problem for one thing, so I'm just going to solve it for that thing.
Well,
Exactly, and that's the problem with generics is it's trying to be a general solution, and usually you haven't got a general question. You haven't got
Yeah,
a general
I think
problem.
generics just add a whole level of complexity onto that you just don't need.
No,
Like, for the language.
I do think generics are needed, but not the type of generics that most people think of generics. Because I think the word generic is stupid and generic in a sense. Like, I think that you need the language has to allow you to have, hey, I want this certain pattern with certain orders, but I don't really want you to generate the exact same
Okay,
code.
so let me give you an example of something that's like, in theory, generics could handle this, but in practice, I just duplicate the code because it's going to cause me a problem. Then you can tell me how you're actually going to fix this, right, for me,
Go
or
ahead.
if you have a way to. So there are a lot of places I have string operations in my meta generator and in my encoder stuff that the string operation has to be written 4 times. And the reason it has to be written 4 times is because some people want it to match with case sensitivity, and some people
Yes.
don't want it to match with case sensitivity. So I have to write one version of the function twice, one that does string match and one that does string match insensitive, right? This function is exactly the same except one call
Yes.
inside the body, and it's buried inside of complex control flow, so I can't really extract it in any way that makes it easy to do anything other than maybe pass in a function pointer, but then why? That's weird too, because maybe I want to inline it, and now I
Yes.
can't, and so on and so on. And then the other thing is it needs to either move seek forward or backwards. So now I have to have one loop that's plus plus and one loop that's minus minus. So I have 4 versions of one operation, essentially, right? How do you make that one code that I write in debug once? Because that's the thing that you actually want generic programming for. Is like it's the same concept 4 times, but there's little things I'm tweaking. It's not the types that I'm even tweaking anywhere. The types were the same the whole time. How do I do that?
For me, I think the problem is actually solved with default parameters, in a sense, and nested procedures as well. So you actually have both together, which solve the same problem. So for you saying you'd have a flag saying, oh, this has to be case sensitive or case insensitive. That's one flag. And the other flag is which order you go. Do you go forwards or backwards? And that's just a flag. But you'd have default settings for them, which you'd explicitly or implicitly set. And then you'd have inline procedures as well that would solve that problem, like, hey, this does this backwards, this does one forwards, just use this one in this certain case. And for me, that is actually a better solution because actually it's the same actual functional procedure, whatever you want to call it at the end of the day. And it solves that actual problem. But having multiple ones actually causes a little bit of a disjoint, in my opinion, because it kind of removes the flow of how a program works, like reading right from top to down. With multiple functions, you've got here's one that's a different solution, here's another that's another solution, here's another. If you have one, you can actually flow. Like, if this happens, do this, else do this.
Mm-hmm.
So I
Well,
think
so-
that's my solution, in opinion.
Yeah, that's true. You could runtime do that, and that's something I've thought about doing. Is saying, all right, at the moment that I go to make the decision, I just haven't baked in line that I always do this or that. I if on it and do it. I don't. I feel like it should. It seems to me like
don't wanna
it's
pay the
something that should
runtime
be known.
cost.
It should always be known at compile time which one I'm doing, because
Yeah.
very rarely is the user dynamically you doing one or the other in a way that isn't predictable. And I just wish my compiler was smart enough to go, aha, hard bake in the behavior here. Even if it was like you write the runtime code, but it knows how to bake flags in the way like Jai does or something, or JAI.
I think the solution to that is literally having like an alias. Like, hey, could I have this function, but it has these defaults inside, and it's an alias to that actual function. So it's easier for the compiler to think, hey, this needs to be either inlined or it has to be referred in this particular way. And I don't think many languages do that in that sense. I don't think I've ever seen any modern language do that. Like, say, I actually want this function, but I want it to behave in a certain particular way. And I don't know if that is the way I want it to do it, or if it actually is the way I want to do it, just no one else is doing it.
See, what I'm sort of getting at is if I could write on a parameter, this is a compile time parameter. You need to know at compile time this parameter.
Yes.
And even if the compiler doesn't take advantage of it because it's like debug mode or something and it doesn't do the code crunching, but that way the compiler could optimize, oh, we always know the values at compile time, so generate different functions for different flags or whatever. That would solve the problem too.
So I've never personally cared about default parameters. I feel like they could be useful for me, but like
I've
never really used them. I've thought about them before, but it's like I'll just pass like one. I'll just pass one every time. I don't care, whatever.
I always find I cause myself a lot of bugs if I use a default parameter. And the reason for that is, and maybe you can fix this too in a new language, but if I have a function that takes two parameters and the second one's default, and it's a default int of 0, and then I decide, you know what, this function really should have an end position that you always specify, and I put that before the default parameter in C++ because you have to. Well, now all the places where I use the default parameter, they're not going to the second instead of the third like they're supposed to, and the type checker can't find that. So I actually never use default parameters because it always breaks things.
Yeah.
I don't know. Language design is quite bizarre because sometimes you may think you want default parameters, but what you actually need is named parameters, not actually default. Sometimes you want to call them as names, like I want this parameter that's named to be called like thing, or blah blah, or blah de blah blah. I don't know, whatever you want to call them.
Just stick with
but you want to call them in certain orders that makes logical sense to you. But the ones you don't call, you just want them to be initialized to like 0 or whatever the default value is. So I don't think default values are actually what you want. I think it's default values, but you explicitly set what the other values that you haven't set is what you want.
Yeah,
I don't know. It's quite weird.
Yeah.
In C# you can basically do it. You still have to put default parameters at the end of the when you make the function. When you call them, you can call you can set all parameters by name. So you can actually stop caring about the order. You just say, okay, I know this has a parameter named end. I can just say, okay, I want end to be 32, but you never specified some of the others that have a default parameter, and then default parameter just gets used, just no matter the order which I put in the parameters. So
Ginger Bells.
What?
Since we're on the topic of your language, do you have var args, or do you have a plan to tackle them better than C?
Oh no, I've completely got var args, variable arguments tackled completely now. I've even got, you're allowed to have any type as well. I have a type that's called any, which means that any type can coerce to this any type. So what it has is its type information stored as one pointer, and then the pointer to the actual data that is stored to it as well. So I have now got a printf, or a print function, that is completely type safe. I can print out everything. I know the elements, their offsets, their types, their names, everything within a structure or something. It works for me.
That's real nice. Okay.
Yeah, and it works, and it wasn't even hard to implement either. And it's all completely type safe. So anything that any type converts to an any. And then from the any, it stores the type of the data, and then the type, the info, and the type info stores what type it is. It could be either an integer, a float, or a procedure, or a union, or a structure, or a raw union, or an enum, or whatever it could be. And then it has all the information like the size, or it has the type, or the signness, or the whatever it needs to be for that type. And you can just gather the data. And at the end of the day, it just kind of works. And it's simple at the end of the day, and it's low level enough that you can do whatever you want with.
Yeah, I feel like if you're using variable arguments, I think John actually said this exact thing in his. If you're already using variable arguments, you aren't trying to get like precision. Like you don't mind that you're adding runtime type information in, because why were you using variable arguments in this? In this.
I don't use them. I just don't like the way C does.
No, and also with my language. The variable arguments like runtime information, I only create memory if you actually use it.
Mm-hmm.
So if you use runtime, the type info procedure, or if you use any type, then I produce that data. If I don't produce that, if you don't use any of them, I don't produce any of that data. So I only produce it if you actually want it.
That's nice.
For me, that's the best option in my opinion, because if you're going to do like an embedded system or something like that, where memory is kind of important, like you don't have much memory. Like in an embedded system, you may have like 64K of memory, or if you may even have like the actual ROM itself is only like a megabyte or something, or even less. If you don't want to use the type information, just don't use it. It will never get used. And I think that's the best option, because JI uses everything. It chooses whatever type you need at the moment and just bakes that in. And mine, I only use what you actually use, is the sense. If that makes any sense.
Mm-hmm.
Yeah.
Yeah, that makes perfect sense. I like.
Because I only implemented this actually about a couple of days ago, and it's quite useful. I already have a complete printf.
Was it? It was in your demo actually,
and it works. I haven't done the demo on the introspection stuff yet. I've only done the demo on the tagged unions.
I mean, I saw your printing going on. I remember in one of the demos, you printing a bunch of vectors.
Yeah, but it wasn't proper printing.
That was using your separate functions to print different things.
Yeah, there was only using separate functions, so it was like more of a C style. So at the moment, I can literally print any arbitrary function, like literally any function. Like I print any structure, like I pass a structure in like a vector 3 or something, and it will say vector 3, open parentheses, x equals 1, y equals 2, z equals 3. So you can actually use that exact printing function and you can pass that into the actual language of the code and it'll understand it.
Well, that's better than
having it's serialization in the end of the day. And it works.
For getting that the data from a vector, because I know some people like to print their vectors. I've never had a reason to. But, some of the solutions I've seen of people trying to like do operator overloading and shit for that, it's insane.
Yeah, you don't even need operator overloading for this, because I just have the type information baked into the language.
Yeah, if I see any bit shifting out in Odin, then that'll be it for me with that language. I don't want
bit shifting built in, but you don't need it.
You don't need it. No,
he means like the see out thing.
I know what you mean like that. No, I am not doing any operator overloading whatsoever, because I think it's not useful, especially when I have vectors built into language. Like literally, vectors are a first-class type. I can do A plus B and equals C.
That's pretty cool.
It works.
Yeah.
Like it solves 99% of my problems. The only problems it doesn't solve is like dot or cross products.
You SIMD them, right?
They're SIMD as well, so like a vector 4 of like a float 32 is equivalent to like a 128-bit SIMD register.
Okay.
So that is literally the equivalence of it, and it'll work.
Good. Yeah.
And you can do swizzle and everything on it. It works.
Do you do that with? Do you have matrices built in? That'd be real nice.
I haven't got matrices, and I don't think I ever will, because the problem with matrices is, if you can support matrices, you just got to support tensors in general.
I just
tensors are useful.
So I don't care about SIMDing anything besides matrices. I just don't like doing it. It's just always been a thing.
Well, it's not difficult even when I have vectors in the language, because you can just say, "Hey, add this plus this."
No, yeah, writing the SIMD code is like really simple with the way the vectors work. What I've been wondering ever since I saw your vector demo, or the demo that included vectors, is how does it handle, like, if you have a vector of 5, does that make one SIMD register and an extra, or does it just throw up, what happens?
This is mainly because I'm having to use LLVM, and LLVM has got weird backend. So if you've got if you've got 8 elements of a float 32, this would probably turn into 2 128-bit registers. So it will do one at the time and then the other. If you've got an odd number like 3 or 5 or 7, it'll have to think like, okay, do I operate on this lot first and then that, or do I operate on this lot and then the other lot, like a different sizes? So do I operate on like 4 and then 1, or do I operate on then 4, like 2 and then 3 and then whatever? And it's the problem is half of that is problematic with LLVM. The other problem is half in my language, like, should I even allow that? Like, do I tell it to do that with the alignment specifications?
Because if not, the thing would become you'd probably want built-in language methods of asking what vector lengths are available here, right? If I can't find out, like, I want to be able to.
I should allow every vector length possible. Is the thing is I don't want to not.
No, yeah, you can write the code, allow the code to be written, but I want to if. I mean, the only issue is maybe you say like, yeah, in theory this is cross-platform compatible, but like if something comes along that wants 8 for, we've got wider registers in the future, we need 8 to fit in, and otherwise it won't work, and now you just got to rewrite your code for this platform.
Yeah, I think it's probably fixed with flags in the compiler, like flag it up for this is what we need, rather than they actually change the code, if that makes any sense.
Okay.
And it's weird. Like a lot of the stuff I've done with like vectors and stuff is problematic, and it kind of works weird because it's not natural to think about. Because naturally we think about like scalars, like we think like 1 + 2 = 3. But instead of thinking like, hey, we've got a vector that's got elements like 1, 2, and 3, and this other element has got like A, B, and C, you don't think of adding them together. Your brain can't add them together at once, if it makes any sense.
Right.
And you kind of think of like individual elements. And how a computer works is that they can do all those elements once, and the representation is not always what you want as well. I'm probably not explaining it very well. Is one thing.
This is what happens when we have 2 episodes of non-programming talk and we just switch into a program.
And also, I have drank a lot through rum is half the problem. It was here, it's now here.
Oh, gosh.
I do like the taste of rum, is the short answer.
I don't like
rum and ginger beer is very good. Ginger beer is very good with it.
Gin.
I've run out of ginger beer, so...
Gin and light beer is surprisingly good.
Yeah, gin's all right. I do prefer rum and vodka as well. Vodka's pretty
vodka's great.
Yes, sorry. Get off of alcohol. Please drink responsibly, kids.
No, drink as much as you can.
You're allowed to drink since the age of 5, but you have to be in your parents' permission or your friend's house.
Woo!
America.
Denmark,
Yes.
drink whatever.
America, you're 21. You're allowed to vote before you can drink.
They're allowed to fight for their country before they can get a nice cold beer at the end of the day.
That's right.
Yes, it makes perfect sense.
No. If they have had the beer, they would never fight for the country.
We couldn't get into so many wars if we adopted the policy you're hinting towards. So
I'm just seeing a brighter future.
But yes, alcohol is. I do love the taste. It's just the effects I'm not bothered with, really.
I like them.
I'm not bothered with the effects. I do love the taste of rum. I do like whiskey. I do like gin and all that lot. And rum. And again, please drink responsibly, people.
Alan can legally speak on behalf of this right now. We're in trouble. Wait, Alan, you're not 21 yet, right? Yeah.
No, I'm not 21.
Yeah.
No.
But you're going to be 21 for Handmade Gun, right?
That's right.
Yeah.
Yes.
Abner said he has plans.
Yeah, I'm sure he's announced his intention.
Again, I could drink since I was 5. It's fine. The law in the
I've
UK
drank
is
since I was
great.
born.
Yes, Denmark is weird. I have been to Denmark before, though. I have been to Lego Billund. Lego Billund was great.
What?
I went to Legoland Billund.
No.
That was great.
Place.
It was brilliant. I was like 7. I loved it. The only problem was that the ship ride there, because when you go on the boat, my parents were a bit seasick, but I was absolutely fine. Like I wasn't a problem with boats or anything like that. I don't have any seasickness. But it was a lovely place when you got there anyway. I couldn't understand any of the words they were saying in Danish, but I still think that, yeah, it was great.
I went to London twice. Your metro system is garbage.
I've only been to London twice as well, and metro system apparently is very, very good, but it's hard to understand.
It's organized like a shit show.
But there's so many like networks that you have to go on.
Yeah, that's exactly how New York is. I've been there, and it's like nothing.
We invented it. Well, did we invent metro system, like the subway system?
I mean,
We've had it for like over 100 years.
All right, let's guess.
Yes.
We've had it for like over 100 years or so, like the metro, the
I'm
subway.
going with America did it because we do everything right.
We invented most things. We invented the television. We invented the radio. We didn't radio. We invented the television for definite.
Got that one actually.
We got that one. John
Lakerbed. Yeah. Well, you got computers, don't you? Like, would you say you've got computers in London? Or in
no, maybe the Russians built the first computers, maybe, but we got the first logic. We got Alan Turing, maybe.
That's what I'm thinking. You've got Alan Turing, which
it was in London, I think.
kind of.
Alan Turing was, but
yeah, rapid transit in London.
What was Alan Turing during the war?
Yeah, I think the UK did it first. I think
we did a lot of things first because, yeah, we did. Just luck mainly.
But you don't have nil spore.
Yeah, we invented most popular sports like football, cricket. American football is an English thing as well. Rugby, baseball is an English thing as well.
Seems like you guys are just giving your good stuff away.
Baseball is actually pure American. So is basketball.
Yeah,
they are pure American.
Basketball. I'm not sure how
basketball is pure American.
Don't they say like baseball? Isn't like
we have rounders in
American
this country.
pastime or something like that. Like yeah.
Yeah, in the UK we have rounders, which is pretty much baseball, but not.
I've never even heard of it, so I don't know. I don't even know what it is.
Sorry, I don't know. It's a really weird topic to get onto.
Yeah, I don't know how do we get transition to this.
Yeah, but it doesn't matter.
Well, time to work this back. Unroll the stack, guys. Throw an exception and figure out where we started.
Oh God, it's hardware exception, not software.
You didn't handle the exception. What I crashed.
Did you catch it? You didn't try and catch, did you?
You didn't try.
No, I never try catch.
Yeah,
I don't know how that works. It doesn't
Did you
sense.
underscore try? That's fine.
The last time I tried and catch was in Java, so
Yeah.
I did try and catch yesterday.
I had to write some try catch for my operating systems class because my teammate insisted on throwing a few exceptions. So I had to try and catch those. I tried to catch them anyways. I don't know if I did. I don't know if I worked, but we passed.
No.
Try and catch some.
Depends on skill level, right? You need to get the proper mitt to catch the actual exceptions.
Oh yeah.
Oh, that worked. No, I missed.
The exception handler didn't work for Zach, and he lost audio.
Oh.
Gosh, I keep my fingers on the button, but I keep accidentally hitting it. But where I was going is
we hear you.
But where I'm going,
Zach.
I heard I was looking like I think it was Lua to like bytecode or something yesterday, and I saw they supported MIPS. And I'm like, who the hell uses MIPS in 2016?
Hey, but MIPS is so cool, man.
MIPS is cool. I agree. Who uses MIPS anymore?
No one.
Yeah.
And I'm sitting here. What's MIPS?
Yeah, I'm actually wondering what exactly we're referring to. I know a few things that sound like the word MIPS.
Right, there's different architectures. So, like, there's x86, there's ARM, there's whatever.
Yeah.
There's MIPS, and MIPS is kind of like saying, hey, we've actually do everything better than everybody else. We're great, but no one uses us because reasons.
The N64 had a MIPS processor.
Yeah. So wait a minute, you're saying Lua bytecode doesn't compile to any architecture.
No, but I think it was Lua Jai or something like that. I was looking at Dimitri.
Lua, yeah, I know what you mean, Zach. Actually, anyway, so
yeah, he was telling me about this yesterday, and it was let me see.
Oh.
Yeah, see, it says it's right here.
That's weird.
I can send it to you guys. This is what I was looking at.
Okay, I see what we're talking about now.
And then I saw that it said performance and it said on MIPS, and I was like, what the hell, MIPS? I was like, who
it's
uses
just an
MIPS
architecture at the end of it, because you got PowerPC and you got ARM and you got x86.
Yeah, it runs on everything, like literally everything.
Lua is a really simple language, though. At the end of the day.
Mm-hmm.
Yeah.
The only problem with Lua is I think it's weirdly designed, not badly, weirdly.
Yeah, it's a very weird language, but like, if I'm going to choose something to do a quick script, and I'm going to choose Lua over Python any day.
Yeah.
Well,
I don't know Python.
let me-
Python's got really good libraries.
Yeah, I was going to change that because Python has better library support, but if it needs to be even a little bit performant, I'll go to Lua.
I just hope my language is better than both of them.
Well,
I don't
what
know,
we
I really
should
hope they
do,
should
I don't know why all these libraries exist for Java and
Yeah.
Python. Somebody should say, like, why don't we make a competitive library in Odin or C or
Exactly,
something like this?
because I've kind of come to this conclusion that the language is most of the reason why people like languages isn't the actual language itself.
it's the
actual
things that come with it,
libraries,
yeah.
the standard library.
Like, today,
I mean, I don't know why C++
today,
is popular then, but
Today, 60% of a language
Boost.
popularity is its standard library.
Like I have so many tools now that are C based, not C++, just pure C based, and they are better than any language that I could ever get, apart from what I'm developing at the moment. And it's
Good
like
catch.
these are standard libraries things. These aren't
these
actually
things, like, I
the
started to
language
realize-
things.
Will Odin have a like an HTTP library server thingy like Go?
Oh god, yeah, I'll probably get server stuff because I already do that for work. Like I'm using Go on few servers already, and Go is actually brilliant, and its standard library is great, and its built-in concurrency model, which is CSP-ish, like communication sequence processing-ish. I'll say the ish. It's great for servers, and the whole reason that Go is built for servers, but nothing else.
The one thing I've realized is like rewriting these like standard library things. They're really not hard. They just take a little bit of time. Like they're really not hard.
it's-
They're
I
not hard
think
at all.
I
Like, there's
think
definitely harder things.
I don't know why. I don't know why it is. I don't want to give credit to these languages, and I think maybe it's just a perception thing. But I think at least the perception is that if you try to do the same thing in say C, that you do in Python, where you just have a massive standard library. The problem is it's going to be hard to include these things and get them to build straight away because there is a lot of history of like you try to get like the zip library, the zlib or whatever. You try to get something like that simple to work, and it is a little bit of a hassle.
Oh,
So
gotcha.
they think, oh, Python is good because it's not a hassle, and I think the only reason it's not a hassle is because you took the time to make it not a hassle to
Yeah.
use, and you could do the same in C. So I'm just not sure why. Like C's been around for 40 years, and it's just because
But
everyone
still-
using it doesn't feel like making their code open source because they can make money on it. I don't understand.
Yeah,
Yeah, that's my
it's been
sad thing about
updated,
C
like,
is
forever,
it
right?
is still the best language.
yeah.
Unfortunately, you can still do everything
I
that
don't know. I
most of
really
the
don't
languages
have like
like.
that big like hatred for C like I do for C++. Like every time I have to touch like a line of C++ code or write a default constructor or or deconstructor or anything, I get real mad. But like for C, that doesn't happen anymore. Right?
No, and C is like most of my criticisms is like I'm missing language features. Like I need to use the macro system
no-
to add those.
There's
yeah,
a
I
few
agree.
odd decisions that are like, if you like had the chance to think about this more clearly, you wouldn't put the subscript here and the pointer here.
Yeah,